to talk to you about planning for disaster recovery with Galera Cluster today. I'm glad a lot of you have shown up, and I'd like to, obviously start off by saying this is a more conceptual thought leadership type webinar as opposed to we're not going to go through demos, we're not going to go through mathematics, we're not going to go through configuring Galera Cluster. Because there are two ways to do this. And again, based on feedback, we may also want to do a webinar, for example, on just a geo-distributed Galera cluster of which we could run fairly easily, or we could do a DR one, and we could demo this even with something like Amazon Web Services, the Azure Cloud, Google Compute Platform, and so forth. So we're going to talk about disasters, trade-offs, the fact that you can actually have a geo-distributed Galera cluster, architecture choices, having a plan for disaster recovery, and sometimes people will tell you asynchronous replication might be the best solution for the disaster recovery. Is it? And of course, naturally some resources as well. So this is an example today of the O'Reilly website. And they have O'Reilly is a fairly famous website when it comes to thought leadership in the computing world, and they are down due to fires and power outages in California. So you can go to O'Reilly.com and you'll see this. And at one stage, even they are learning.o'reilly.com, which is where you can read all sorts of books if you have a subscription and so forth. Was also down, but they are still obviously going on with this conference. So this is a current event in California where all kinds of IT happen, and they are websites that are going down largely because it would seem that O'Reilly doesn't have a disaster recovery plan to keep the entire website running elsewhere outside of California. And it turns out there are so many different types of disasters that could happen. You could have environmental, in this case, fire, power outages, but it's also like hurricanes, tornadoes, floods. You could also have, biological stuff, with regards to the illnesses that affect lots of people, for example. You could also have deliberate stuff, fraud, bomb threats, utilities, in this case, also loss of power, equipment breakdowns, things like hardware failure, data loss. We hate data loss in the database world, obviously, and we're Codership, the people that make Galera cluster. We don't believe in data loss, and of course there are so many other reasons why you need a disaster recovery plan, because you could also be losing, say, key personnel, and key personnel leaving could mean that you could be in a very serious disaster, so to speak. I also can give you other examples. For example, data centers burn down. So, I once went to South Korea around April of 2014, obviously, and I could not use my American Express charge card anywhere. And the reason was because the people that process American Express in Korea is Samsung, and it turns out that their data center caught fire, and it affected American Express for 1 week in South Korea. But it also affected their smart TVs. So you can't really buy a dumb TV anymore. So your smart TV functionality would have gone away. People who had Samsung phones and they used to have a chat service called S-Chat, that went away as well. And it turns out this sort of thing happens. Data center fires take away a whole data center, and they did not have a disaster recovery plan to keep everything going, because typically the most expensive kind of DR plan involves you having another data center waiting for you. Also, floods can happen. If you read the top left-hand corner, this is actually Hurricane Sandy affecting New York, where at least 8 data centers were down, struggling with connectivity because it was starting to flood inland of downtown Manhattan. And flooding was basically submerging and destroying diesel pumps and preventing fuel from being pumped to the generators at a higher level. And it turns out that this is not good. So again, lots of websites went down and had outages. And of course, you could also have seizure by law enforcement. The FBI could come in and say, hey, we think this is bad, we're going to just take away your machines. You need some kind of disaster recovery plan against even, say, law enforcement, generally speaking. And there are also, of course, all these trade-offs that you may need to think about, right? Business considerations include obviously having the highest uptime and the cost on business impact, as well as risk management. And you need to think about offsite data storage as well. You always think about scalability, reliability, resilience, as well as performance. And there are many, many different thoughts here, right? Around scalability, you want the agility and the ability to grow and consolidate. That means maybe have more instances when you need it, scale back when you don't. And that's what the cloud is kind of famous for. You also need to be resilient against hardware failures and network flaps. You need to be reliable as well to make sure that your data has got integrity. In terms of performance, you have to always be close to your users. So you totally have to ensure that you have your application servers, your proxies, etc., running close to your user as well. Something that a lot of people, I think, don't really think about when they're doing a disaster recovery plan. They think, hey, let's just make our databases disaster recovery proof. But what about your app servers? Like, who cares if the database is still running, but the app servers have gone away? Who cares if the proxies have, people also care if the proxies have gone away. You have to have your whole stack disaster recovery proof, so to speak. So it's not just a 3-node Galera cluster in another data center. It is potentially, a 5, 6 node operation before you even think about having a second DR site. So I mean, you've come to a Codership webinar, so I'm going to presume that you know a lot about Galera Cluster already. So I'm not going to go too much into what Galera Cluster, does. But Galera Cluster officially, we talk a lot about high availability. We give you the ability to have multi-master applications, so all nodes are equal. It's obviously a synchronous, virtually synchronous cluster, so that you are always available. That means when it's time to commit data to the node, it starts committing to the other nodes and then certifying that it is correct. There's also quorum-based failure handling with optimistic concurrency control upon a commit. And of course, it works really well when it comes to wide area networks as well as the cloud. And I have a diagram later to show you how this happens and what I mean by it as well. And then of course we have to talk a little bit about base replication, right? We have asynchronous replication where you can have insert hitting a primary, and then it may or may not hit a secondary, and you may have something known as secondary lag or 10.2 even, and even 10.1. Now the thing about asynchronous is you can also have an asynchronous cluster, right? You could have asynchronous Galera clusters too. So Galera can run synchronously in one data center and be asynchronous to another data center, and this is perfectly okay. Then there's the other fairly common one called semi-synchronous replication, in where another secondary at least receives a transaction. So if you lose a primary, all is still generally well. And this is how lots of people on the internet tend to run services. So I mean, if you use a free service like Facebook, you can't expect them to guarantee your uptime all the time. Of course, they do, generally speaking, because they know users get really angry when a like is missing or something. But the reality is the SLAs could be a bit less focused than, say, if you're running a online gambling website or some kind of e-commerce website. And then of course there's Galera cluster, where all nodes contain the same data. You don't need a framework to handle failure. It's all fully built in. And Galera cluster allows you to have clusters of clusters across data centers. And that actually is, kind of fascinating as well. And like I said, it's probably, the most automated solution available out there when it comes to dealing with disaster recovery. So, how does this all work when it comes to dealing with disaster recovery and multiple data centers? Galera, of course, supports being run in multiple data centers. You can have a 9-node Galera cluster across 3 data centers, and you can be extremely highly available. Galera, totally supports geo-distributed database clusters, and we wrote a blog post as well as a knowledge-based document about this as well. So, effectively, in this particular diagram, you will see that I have 9 Galera cluster nodes spread across London, San Francisco, and Singapore. Now, the interesting thing is you also need to have your app servers and your proxies in London, San Francisco, and Singapore, so that when your application writes, say to London, it's doing an insert into London, it'll hit G1, for example, and then when it's time to apply, it'll have to apply to G2, G3, either one of G4, G5, or G6, and either one of G7, G8, G9. So it'll write to 5 nodes across 3 different data centers when it's commit time and when it's time to certify. And then an elected node in San Francisco and Singapore will then also replicate out locally via segments that Galera does support. Now, can your application allow you the latency? Do you have the links as well to ensure that your application receives minimal latency when it has to write to 3 nodes in London, 1 node in San Francisco, and 1 node in Singapore? Now, this could be relatively easy when you have something like, Amazon's network. But if you were storing stuff, say, in rack space in London, and you had a data center like maybe Hurricane Internet in San Francisco and another random data center in Singapore, which don't have interconnects with each other and they have latency. This could be a bit of an issue for your application when because it cannot tolerate long commit penalties. Now, an insert could be extremely simple, but a long running update could cause rollbacks, which you're trying to obviously avoid. So Galera, of course, has extremely good network protocol, but you also have to think very carefully about how that works. So there are so many benefits of a geo-distributed cluster. You of course have increased redundancy. Um, you have the database operations that are being kept local, so it's all very nicely segmented. Your network traffic, of course, reduced across data centers, also with optimized bandwidth consumption, because earlier versions of Galera did not have optimized bandwidth consumption. You'd have to write to all 9 nodes. Now you only have to write to 5, and that you're saving the writes to 4 nodes at any given commit time, and that is extremely efficient and extremely smart. You also, of course, have latency penalty is obviously as minimal as possible. But remember, when it's time to commit across all nodes, you also have to think about how long it takes for the data to reach the other node. It's always going to have latency from distance because obviously we cannot beat the speed of light and so forth. You can fully configure flow control, and we'll talk about flow control a little later as well. There's also no split brain issues that you get with a Galera cluster, a 9-node Galera cluster. You also get out of the box encryption, so you can have SSL at any given time. And of course, this also works with asynchronous replication. So the example I've given you here is fully synchronous Galera cluster, 9-node multi-master. But the reality is it can also be asynchronous. And remember, the penalty obviously for synchronizing nodes over high latency links is incurred at commit time. So there are no delays of communication between remote nodes during a transaction itself. But Galera itself does not use distributed locking, so each row level lock does not have to be communicated across data centers. But you have to think about high latency situations where the complete avoidance of slave lag is obviously not required, because we also do allow asynchronous replication between these 2 otherwise independent Galera clusters, each running in its own data center. And with the fact that we have parallel replication now, this in many of the database servers like MySQL and MariaDB, it makes a lot of sense that it's potentially a good option for you as well. So when it comes to architecture, if you're doing a 9-node Galera cluster at the minimum, you also think about, your application clusters as well. So you've got a 9-node Galera cluster. Even if you had 2 app servers and 1 proxy, that's 3 per data center. So you're now looking at 18 nodes, and it's very good for high availability and disaster recovery because all this is fully managed for you, or at least on the database side. But it gets costly. I mean, how many of you can just easily spin up 18 nodes across 3 data centers and say, hey, this is good? It's a pretty hard sell because I've seen a lot of people wanting to save costs. They want to do high availability as cheap as possible. They'll put 2 nodes in one data center, one in another. They don't mind that the application has commit time penalty, for example. It's a case of money is more important if we save it somehow. But when you're doing high availability and you're thinking about disaster recovery, money shouldn't be as important, because disasters do occur, and they occur more often than you think, actually. Just, a good example is what's happening in California now. I mean, it is, if you look at the economy, it is maybe one of the richest nations in the world, even though it's just a state, and they're having, regular power outages due to fire. Also, when you're doing a 3 data center 9-node Galera cluster, you have to make sure your schema is planned very well, because you don't want to have hot rows, deadlocks. You don't want to have performance issues that have rollbacks. Uh, it may not be the best solution if you're having a ton of updates. If you're having a ton of updates, you may need to start thinking very carefully about how you write those updates, and maybe focusing on not being at all 3 data centers, doing the updates at once. But um, you know, uh, there are plans around this as well. Anyway, we here today are to talk about disaster recovery. And disaster recovery largely is the ability to run your business continuously without any interruptions, irrespective of any damage occurring to your infrastructure. DR is not cheap, neither is proper high availability. It really pains me when people tell me we want to do a highly available Galera cluster, but we only want to have 3 nodes across 2 data centers. That hurts. This is you need to really think about, this so-called backup cost that you need to think about. The Linux kernel has had something called DRBD for a very long time, RAID over Ethernet, and that's something that lots of people have used as well, for disaster recovery, um, from a block level situation. But we're not going to use that because we're focusing on Galera cluster. A good DR plan also is your business continuity plan. And you need to think about all these things like a recovery time objective, which is a time scale, in hours or days, which this must be achieved, that you see is operating in a business. And also the recovery point objective, which you want to make sure, like, hey, can I get data back from that a certain time period? So, and how much data can you afford to lose? Now, nobody likes to lose data. Everybody thinks they've got 100% of their data at all given times. Now, if you're willing to go a 9-node Galera cluster, you can, across 3 data centers, have 100% of your data kept available for you. But if you sort of have to cheap out a little bit, as most people end up having to do, you'll go async replication. Then you need to say, look, I've got all this latency, I've got this potential slave lag. I'm going to maybe lose, the last 1 minute worth of data, the last, 5 minutes worth of data. And again, it all comes down to what you can tolerate as a loss of data, as well as a balance between that and the cost that it's gonna cost you to keep, this additional data center alive. But largely also building resilience into your infrastructure. Now, cloud people totally understand resilience. Cloud instances tend to be of varying quality. So in the preparation for this webinar, I spent a lot of time with cloud instances on Amazon, for example. And you can, you need to, every time you spin up an instance, you need to make sure you've got a baseline of what the instance is supposed to provide. You could spin up more instances on, say, older hardware. You wouldn't even know. But you need to have a baseline benchmark before you launch your service. So of course, this takes a bit longer to launch said service, but if you have a poor baseline, you can kill and restart at any given time. And I spent a lot of time playing with this thing called a toolkit called the Simian Army. Chaos Monkey is very interesting because it just kills nodes at any given time. Now, if you're running a 9-node Galera cluster. This is awesome because you're just killing random nodes at any given time, and you're going, hey, my database servers are still running. Now, Chaos Monkey can also be orchestrated to kill your app servers to see if things continue running. What I really like though is latency monkey, because lots of people say, hey, we've got pretty good links, but if you introduce latency monkey and you do and you then also use Galera, obviously, you will actually see how long it can take to actually make a commit, and this takes ton of effort to do manually. But latency monkey exists, and it's amazing for you to plan how much tolerance you can have to data being delayed, for example. And then Chaos Gorilla is another one. It can actually drop a whole availability zone. So in my earlier example where I split things between London, San Francisco, and Singapore, you can actually just even drop that those are regions, but you may want to have more than one. You may want to have Galera cluster across availability zones, and you can drop an availability zone uh, easily with Chaos Gorilla. And in fact, in the last few years, it's even spawned sort of an engineering field called chaos engineering, where you experiment with production in order to build confidence in the system's capability to withstand turbulent and unexpected conditions that could be introduced via, disasters. But you need to plan for disasters, hence the ability to use things like Chaos Monkey, Latency Monkey, Chaos Gorilla. There are plenty of other tools that come with the Simian army that you could also make use of. What else do you think about? You obviously have to keep track of the mean time to recover because, hey, like if I'm switching from one data center to another, or if I'm degraded running in just two data centers, I need to know if there's any mean time to recover. Now, if you run Galera fully, your mean time to recover is more or less basically zero if you just lost one data center. But if you're doing the async stuff, you need some kind of framework to make sure that you've switched DNS and so forth. And the other one that's really important is the mean time to detect. How long do you actually know before a disaster has struck, and can you move your workloads? Now, again, with Galera, this is configurable. You can also eject nodes inside of a cluster, but the mean time to detect has to be really low as well. And then what is your SLA, your service level agreement with people, your customers, your people in different departments and so forth. So, when you have a plan, with Galera cluster, the plan is actually kind of easy. You really think you just need to ensure another data center is going to take over. So you have a three node, three data center setup. But if you're going to also do disaster recovery on the cheap via asynchronous replication to another data center because you only need two data centers and not three, this is also okay. But you have to make sure that you're starting to fully automate all of this because Galera is just, there's going to be one sort of passive Galera cluster potentially, or maybe it just is there to serve reads in the second data center. But you need to have some kind of automation solution around it that doesn't normally exist unless you're willing to go out there and just use Galera cluster. So there's going to be some additional work that you'd have to end up having to do if that is what you want, if you want to do to save money and do just two data center situations. And you really have to think about your entire stack because beyond the database, you have to ensure that the DNS switchover is going to be quick. So you got to keep a very low time to live for DNS. Your application servers obviously need to be running in the other data center and be able to take the load, right? Sometimes people allow the application to maybe read and write from both data centers. Like if you had a full Galera 3 data center setup, you can let the application read and write to all three, and it would be independent of each other, and it will synchronize, and it'd be great. Also, if you're using a proxy, that too has to be there. So really, to mitigate from a complete disaster and to have great performance, you have to make sure you obviously got great replicas on a remote site of your entire architecture. So if you're going to go the async route, you do need your entire architecture also, available on the other side. So this is typically what people do end up also doing sometimes when they are trying to save money. You'll notice that from having potentially 18 servers, when you include the app servers and the proxy, we shaved off basically 6. So we're now at 12. It could be even less. So typically, what would happen is you'd have 3 nodes in London, and then there would be an asynchronous replication operation going to Singapore. Now you can have your app servers and proxies actually, even in Singapore, read from Singapore and write to London. This is also a possibility. But of course, it's a degraded experience for your Singaporean users. So typically, if you're going to focus fully on disaster recovery alone and you want to go async, maybe you're just keeping app servers, the proxy, as well as the Galera cluster, say in Singapore, relatively idle. Now, again, lots of people don't like to provision hardware and leave them relatively idle because at some stage a CFO comes along and says, "Hey, why am I paying for double the resources for the potential of a disaster that may occur once every year or 18 months?" And the reason is you have to ask yourself, how much downtime can I really afford to have? And if you really can't afford to have downtime, then maybe you really don't want the async replication option. You want the whole Galera 3-node cluster option as well. So why async replication between data centers for disaster recovery? For one, async replication in MySQL 5, 7, and 8 are really very fast. And it's similar again with MariaDB 10.3, 10.4, and it's been since 10.0, and 10.1 even got more or less automatic uh, uh, enablement of parallel replication. And you can have multiple SQL threads as well. Um, the idea of having lagging slaves really shouldn't be too much of an issue nowadays. You can tune and configure this. Of course, again, this is very workload dependent. You have to obviously ask, is fully synchronous replication right for your application? And there's also this thing called Mark Callahan's law that a given row can't be modified more than once per round trip time. So when you think about geographical dispersed solutions, we also have to remember that IP datagrams will magnify writes at transmission as well as latency. So you are going to have network delays, and it's going to increase the time for certification commit as well. You can naturally know that there's a distance there, obviously with regards to how fast light travels, but then you also have to remember that you have to split the data into datagrams, goes on the internet, and so there is no real trustable measure per se. So Marco Tusa is a blogger consultant, also done a practical example. There are two fairly good blog posts here about a practical example where they had unpredictable delay, um, and Galera would also see that as a network issue. So if you don't have good network, it could be a problem. And then nodes can get evicted from the cluster, and then you have unspecified network issues. So a tightly coupled database cluster basically um, can't locate nodes outside a distance that is longer than the largest round trip time of the shortest desired period of commit. And he came up with this diagram, also fairly similar to exactly what I had a couple of slides before this, where you'd have async replication between DC1 and DC2, though the diagram sort of implies that it's a fully synchronous replication. It's you just actually write to data center 1 and you read from data center 1 or 2, and your application obviously can go fairly quickly. So there are some obviously simple reasons around why some people obviously pick the async option. Of course, the best option is the priciest option, but the priciest option gives you data consistency across all nodes. The Also, you need to ensure your application is ready for synchronous replication. So, you got to be able to take the commit time penalties, for example, and you need to have a very high performing link for application. So it's good if it's within, like one cloud vendor, for example. It is less good if you say, hey, I want to run in Amazon's cloud, Alibaba's cloud, as well as Google's cloud, because they don't really have interconnects with each other. The other approach, of course, is the local commits, where you just have a 3-node cluster in one data center. You'll obviously see different data across 2 data centers because you have an async replication. So the second data center is likely to have a delay of some time. Maybe it's a couple of seconds, maybe it's a couple of minutes. Again, it's something you really do need to look at, keeping in mind that Galera needs you to use row-based replication as well. So if you're doing a large update, for example, you are actually also shipping those rows across the network. It's not a statement where it can just be executed on the other side. This, of course, works, also interestingly fairly well across geographies. We always think that small latencies, like a ping time of 3 milliseconds, 4 milliseconds, isn't a lot, but it is actually. Small ping times, low latencies, they still affect you when you have large amounts of data. So, are you just doing one insert, or are you doing many updates? We don't really know. You can't really tell either. So you need to plan accordingly. And of course, the flow controls the receiving queue, and the queue of events can grow. And the longer the queue is, the longer it'll take for certification as well. So, if you go the async replication route, it doesn't absolve you from needing to find an automatic failover framework. So it turns out that's one of the good things about Galera cluster and having a 3-node data set, 3 nodes per data center across 3 data centers, is you do not have to do manual management of finding a framework. Galera just provides it for you. As yes, it's true. It is the most expensive solution out there in terms of resources that you need, but you don't need to go find an automatic failover framework. Now, if you followed the previous slide, you end up needing some kind of automatic failover framework. Maybe you'd have to run MHA on the servers with a proxy on it, or maybe you need to run replication manager, um, or many of the options that are available for that. So you do need to do configuration. It's not going to be something that's just a drop-in super easy thing for you to do. Whereas setting up Galera cluster, you could spin up each data center with 3 nodes in probably less than half an hour, and across 3 data centers, it should be all in an hour. And if you're going to configure this by configuration management, as you probably should, where you use something like Ansible or Puppet or Chef, it should be fairly quick in terms of starting up a cluster. It doesn't also absolve you from having the fact that you need a good backup and restore solution. So if you're going to do 3-node Galera cluster across 3 data centers, that's 9 nodes, you probably still need to find the least busy place to also take backup, either via MySQL dump, Async, XtraBackup, and so forth. And also you need to test the restores naturally. So backup and restore is still extremely important. If you do the async replication route, it is a toss-up between where should you run your backup. Should you run your backup from the disaster recovery site, because it may be obviously a little delayed, which is fine because you don't run backups 24/7. You tend to run backups at certain time, or do you run it on the production side? And naturally, if you're doing the async route, I think you should run it on the disaster recovery side probably. But then also you need to store your backups elsewhere in case your disaster recovery site is the one that ends up having issues as well. And of course, you also need to have a good rule-based solution for load balancing. So you use something like Proxy SQL or MaxQL, both of which are level 7 proxies that understand the MySQL protocol, that work with Galera. And it's the ideal thing, I'd say. You can also use HA proxy naturally, but HA proxy is it doesn't understand the SQL protocols. So it's not as good as proxy SQL or MaxSQL when it comes to production use cases. But you do probably want some kind of rule-based solution for load balancing. And also, if you're going the async route, it can also help to move traffic over to another data center as well. So we're coming close to the conclusion because I think we set aside 40 minutes for discussion and 10 minutes in the end for Q&A of the 50 minutes we have. Um, so what are your ultimate choices? I think you have the money and the ability. I'd go for 3 data centers so that you have a fully synchronous cluster with 9 Galera cluster nodes. Of course, you also have to add on that count because you need additions to your application servers, your proxies, etc. But you don't have to worry about having automatic failover frameworks. You don't have to worry about asynchronous replication. You don't have to worry about delays. If one data center goes away, like London goes away, San Francisco and Singapore are going to still serve without any issue. And I think that's probably the best solution if you have the money. However, if you're under budget constraints, the async replication option is not bad. You only need 2 data centers, but you still then do need to configure all the manual glue, as I like to call it, um, because it doesn't work automatically. You're going to have to figure out how to switch DNS over. You're going to have to do a lot of these things just manually, and otherwise someone's going to get pinged via a pager of some sort. So I am always of the belief that you should probably focus on the what you could probably do is the 3-node Galera cluster, but 3-node across 3 data centers. But if you can't afford it, then obviously that's fine too. So this is the quote is a dread of a disaster makes everybody act in a way that increases the disaster. And this is maybe coming back to the military ideology of having prior proper planning, preventing piss poor performance, 7Ps. And a disaster recovery plan is only as good as the ability for you to have executed, tested, and again, recovered from to ensure that you don't have issues with your services running. So that's obviously extremely crucial. And we, of course, at Galera Cluster have some interesting resources. The first one's about managing flow control and the flow control queue. The second one's about auto eviction and how it evicts nodes. So you can evict a whole data center, or you could also evict some nodes in a data center, and you'd like to obviously spend some time looking at that. Streaming replication is a Galera new feature which allows you to you execute large transactions more than 2 gigabytes in size by streaming it long before it needs to commit. And this is also obviously actually an improvement that could help if you're doing a 3 data center, 3-node per data center Galera cluster. The ability to back up your cluster is also extremely important. Highly recommend you take a look at that. And a geo-distributed cluster is what I was talking about earlier. The whole, again, 3 nodes per data center, 3 data centers, and we have got a bit of a tutorial on how you could set up a geo-distributed cluster as well. It turns out disaster recovery is an extremely popular topic, and you could read a bunch of books on it as well, with some with mathematics in it. So disaster recovery and business continuity is a pretty good resource. Disaster recovery, crisis response, as well as and business continuity management desk reference, also a pretty good resource. Business continuity and disaster recovery planning for IT professionals. And now, while the effective MySQL backup and recovery book does not cover Galera cluster by itself, it has pretty good topics on asynchronous replication, as well as the ability for you to think about a disaster recovery plan. Now, it's written by Ronald Bradford. He's relatively well known in the MySQL world. It's a fairly good book. The only reason why it doesn't really cover Galera cluster, it's also because it comes from Oracle Press. So naturally, it's not one of the things to talk about a product that builds on top of them. But some general topics there are pretty good as well to give you a fairly good, well-rounded view of backup and recovery. So yeah, with that, I'm going to open it up for questions for the next, I guess, 9 minutes we have for questions. So you can type your questions in the box. Is that true, Sakari?
Yes, they should be, or everybody should be able to do that, yeah?
So any questions, anybody? So we have a first question, which is what about managing segment and flow control to minimize the network latency penalty across data centers? Yes, we can. So with Galera, we do manage segments. So you will segment your cluster fairly well across 3 data centers. Uh, the problem about limiting flow control or even configuring it is we do not know, and you do not know if you're going to see one insert or an update that takes 1 GB of row replication, and where that's where things get fairly intense. So the best thing I can tell you is multiple data centers. But if you have a question that's more specific, again, we can definitely get to that offline as well.
Hey,
So there's
Colin,
another question. Yep.
I had an issue with hearing you for the last couple of 30 seconds. Maybe you do want to repeat that if everybody else is having the audio issue as well.
Oh, okay, yeah. So, last 30 seconds. So yeah, as I was saying, if you happen to use a network like within Amazon, for example, or within Azure, you should be fine. But if you're going to go across data centers, this could be a little bit more interesting. And and you and we can definitely take these sort of questions offline with regards to how we could best configure flow control. But with regards to network segments, yeah, we fully expect that you would configure it, and we handle the fact that you don't have to um, do anything odd to make sure that it works. How do we troubleshoot errors and certification errors in multi-master? Now, of course, you can see the error log and see what kind of errors you're actually getting before we fix certification errors. It could be many reasons why. It could be nodes coming out. It could be a flappy network. It could be transactions needing to be rolled back. Now we do document some of these errors, or maybe I'd say all of these errors as well. So maybe you'd like to take a gander at the documentation. If you cannot find such information in documentation, Codeship sells 24/7 support services, and we also sell consulting. So we're more than happy to go through your error log and help you troubleshoot these errors and certification errors for you. Now, again, so just enable the error log. Um, is a 3-node cluster in 3 data center only recommendable in Galera 4 and streaming ablation and what with Galera 3 async? No, Galera 3 runs just fine in a 3-node cluster in 3 data centers. Yes, we are introducing more features in Galera 4. And the first one that has said features is obviously MariaDB 10.4 with Galera 4 as streaming replication. But we have additional features that are available in the MySQL variant that's coming out in a couple months or month. Sakari can tell you a little bit more about when, but there will be obviously more functionality in Galera 4 across three nodes and three data centers, but Galera 3 runs just fine. 3 nodes, 3 data centers without issue. So you can definitely focus on using Galera 3 as well. So someone says we had a situation where 1 or 2 or 3 nodes are down when you have HA error, no reference row. Yeah, so we do actually document this as well. This is not Galera specific um, error. I think you probably had something with regards to foreign key constraint, and it probably broke replication. It might have broken even regular replication as well. So maybe take a look at your potentially foreign keys because it couldn't find this row in the multi-master cluster possibly. So yeah, you might want to just see if it's also something that got fixed in a later release. But again, we could totally take that offline as well. But it's a handler error when you get the HA error, no reference row, basically. It's most likely foreign key related as opposed to anything. So that's the best help I can give you without seeing exactly what triggered it from the error log. Again, we can totally take this offline as well. So a bunch of you did say you've lost a lot of sound. Somebody obviously got tricked by daylight savings time. Slides will be available later on. It will come to you via some kind of magic email that Sakari will send out. If you have a 3 data center, 9 node cluster, how do you configure local groups and remote links so that data is only transmitted? So yeah, we totally focus on doing that via segments. The segmenting documentation is also at galeracluster.com, so I highly recommend you take a look at that. So caveats and or recommendations in case 2 different cloud vendors for main data center and DR are required. Yeah, if you're going to use 2 different data centers, hi Louisa, by the way. Yeah, you probably definitely want to measure the interconnect. You can also maybe use Simian Monkey um, tools to see the Simian Army tools to see what kind of latencies you're going to get. But if you're going to run between 2 different cloud vendors, um, possibly you're going to go focus on async for disaster recovery purposes, as opposed to fully sync. Again, fully sync across 2 different cloud vendors could be a bit of an issue, largely because um, your application is going to suffer a performance penalty during commit time. And again, we can't control that across 2 different data centers. What about storage? Should it be replicated? Well, Galera stores everything locally on each node. So, we're not telling you to go have something like Cluster FS or some kind of replicated file system. You just need to basically store stuff on each and every individual node. Can we check the database table consistency in Galera? Yes, there are tools to check table consistency of MySQL in general. So you could use something like, PT checksum, for example, from the toolkit, PT table checksum, and that can totally work for you as well. So yeah, there are tools available out there for this, and I believe even like if you go look carefully on the MariaDB blog, you might find how an example of using PT table checksum with MariaDB Galera, and you can use that naturally with any Galera. Okay, so we are officially at 50 minutes. Oh, how do we monitor? When will slides be? It'll be available, I guess, right after this. And I guess, well, we've got How do we monitor Galera replication health, network latency, apply queue, etc.? We expose all of this when you do things like show status. We also in Galera 4 have some extra MySQL tables. So you can monitor Galera fairly easily. There are plenty of tools that help with that, including open source ones and closed source ones. You just need to, look at the status variables that come from MySQL and Galera, so to speak. We also actually have this wonderful documentation on the Galera cluster website. I did not include a link to that, but if you Google, monitoring a Galera cluster in our documentation, you will see that it talks about the status variables, typically anything with WSRep underscore something. But you can also, of course, look at replication health from status like, is the flow control being paused, what the distances are, are things happening sequentially, parallelly? I'm pretty sure all this is very well documented at galeracluster.com. And again, it's focused on using these status variables as well as the monitoring a Galera cluster. Okay. Are there any tools for configuring, tuning, flow control? No. Besides the documentation, we don't really give you tools, but this is something, I guess, anything you get literally out of a consulting engagement or even a support engagement. We focus on things like how much right side caching you will need and so forth. So yeah, really no, we don't have a tool for that, no. But maybe at some stage there will be some kind of tool that helps with that. I don't know. Okay.
Okay, that
So
probably covers it. When it comes to the slides and the recording, it will be available tomorrow or day after. And when it comes to the Galera 4, it has been coming for some time. We expect it